The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to the Aculon NanoClear webinar. Today we're going to talk about a case study on NanoClear implementation. This is a really exciting story of how nanocoating helped as part of an SMT process improvement project to reduce defects by over 50% and increase throughput by over 20%. Let's move to the next slide. My name is Edward Hughes. I'm the CEO of Aculon, and we are the producers of the NanoClear Stencil product. I'm joined with me today by two terrific people on this webinar. Shea, who's the president of Shea Engineering Services, an independent consulting firm, and widely regarded as probably the most knowledgeable person on nanocoatings. She's been researching and studying this area for over 6 years and has written numerous papers and is highly regarded and sought after in this space. And I'm delighted to also have with us today Jimmy Crow, the Senior Project Engineer from Rauland, Division of Amatec. Jimmy has been an advocate of this NanoClear and is an SMT process engineer by training, and you'll hear some of the great work that he's been doing to improve the performance of his organization as well. Move to the next slide. Today's presentation, we are going to give you an overview of what NanoClear Stencil Nanocoating is about, in case this is the first time you've heard about it. I'm going to give you a little bit of a history and share with you some of the users. But the majority of the time is really going to be focused on this case study. It's all about SMT process improvement at Rauland, and it's going to be an interactive interview between Shea, an expert in this space, and Jimmy Crow, a seasoned practitioner. And they're going to talk about the things that they did at Rauland to basically get process improvement, share with you some of the business case assumptions, and then share with you the actual results, which is terrific, as well as a great example of the cost savings calculator. The presentation today should take about 35 to 40 minutes, and we'll leave time for questions and answers at the end. The webinar is being recorded, so there will be a recording available on our website afterwards. We'll be sending a link to all the participants. That link will also include the ability to download slides, so everyone will have that. And then as we go through this webinar, if you have questions, please type them into the chat box you'll see at the end. And at the end of the session, we'll try and take as many questions as we possibly can to address things. So let's move to the next slide. So what are stencil nanocoatings? And hopefully by now most of you are pretty familiar with them, but if this is the first time hearing about it, it's an extremely thin flux repellent film that's applied to the underside of the stencil and to the aperture walls. This product has been in the marketplace for probably 5-6 years and has done a terrific job and lots of proven data on improving quality, giving higher yields in production environments, improving transfer effectiveness. We've also seen the ability to boost productivity because of less under-stencil wiping allows the greater throughput and less downtime because of paper changes. And then finally, obviously, as engineers, you're all tasked with saving money. This will do that by reducing costs, by giving you less rework, and lowering the cost of the paper and solvent that you use in your wiping process. So today we're going to really get into a great case study on this. So if we can move to the next slide. This product has been used and is used by many leading companies around the world, and this is just a selection of some of the names of people who use them. We're based here in San Diego, and Qualcomm's here, and for example, every stencil that is qualified is has this product on it. We sell this product on a global basis to contract manufacturers in Asia, as well as obviously in North America and Europe as well. And obviously, we're delighted to have Rauland as one of our key users, and you'll be hearing their case study today. The product has been extremely well received. It's won numerous awards. You can see a couple of awards here, New Product Introduction Awards and some Global SMT Awards. It's also been featured on the cover of several publications because it really does do a terrific job of basically improving productivity and reducing defects. So it's well respected and well known. From a distribution basis, Aculon services the North American market directly. We have a partner in Europe, Caplink, out of Amsterdam, who has a distribution center in Rotterdam, and they service the European market. And then we have a series of distributors in the key Asian markets that service our product there. In addition, we've been a long-time partner with ASM. DEC is now part of ASM, and they carry the product on a global basis. So with that, let me turn this over to the main part of the show. This is going to be an exciting part, but we've titled the case study, How Nanocoating Helped Reduce SMT-related defects by over 50% and increase throughput by over 20%. And Chrys is going to kind of do the anchoring and the interview of this. So Chrys, let me turn it over to you.
All right. Thank you very much, Edward. And as you mentioned at the beginning, I've been working with nanocoatings and all types of stencil printing improvement processes for a long time. And I think it was this past year at Apex when I met Jimmy Crow. And I know we've got engineers on the line, you run into another engineer that thinks the same way you do and you hit it off instantly. And that's the kind of chemistry Jimmy and I had, because we have the same type of feelings and inclinations towards stencil printing. And we got to talking, and he told us all the great results he's had with his stencil printing improvement process. And we got to talking, and here we are now. So I'd like to take a moment to introduce Jimmy. And Jimmy, tell us a little bit about yourself and the products you build.
Good morning, everyone. My name is Jimmy Crow. I'm a senior project engineer at Rauland. Background, I spent 10 years in naval intelligence. I started my SMT career as a machine technician, and then I became an SMT process technician before becoming an SMT process engineer. I'm a certified SMTA certified process engineer with most of my experience in SMT processes and process improvement methodologies. I work for Rauland-Borg. We build PCBs, 4 to 8 layer PCBs, but we place BGAs, PCBGAs, QFNs. Typical double-sided boards. Our smallest part to date is a 0402 Imperial. We're moving to 0201s. We have a factory here at the factory. We have 2 shifts, and Rauland has been setting standards for integrated communications technology for more than 80 years. We build, practically, we build nurses' call stations and school bell systems.
Excellent, excellent. And my next question for you is, why did you pick the stencil printing process to cut your costs and SMT over the others? And how did you go about identifying the best practices and where to attack it? And I've got your T-bone chart up now with all the different variables.
And so when this was a project I started to identify, we had a large number of defects, obviously, being captured at our AOI, end of SMT line process. So I decided to go for the low-hanging fruit, as it were. Studies have shown that 65% of defects on SMT lines come from the screen printing process. So this was certainly the case in my factory. So I started concentrating on the screen printing process to have the biggest impact overall on yield. Throughput, quality, downtime costs. I concentrated primarily on process improvement, which in turn increased our process capabilities.
All right, and this is an excellent, what we used to call fishbone, now we call a T-bone diagram that outlines all the variables in the stencil printing process. Those of you online, you definitely want to download the presentation, especially for this slide that some of you will probably hang in your cubicle or office. I know I will. So tell us, Jimmy, how you decided to attack stencil printing.
Well, initially I started with what I thought was the most obvious thing. I started with the screening, the things that actually clean the screen mechanically, the paper and the underscreen solvent. So that's where I started, and I got a lot of information on different types of paper. I ended up with a paper I thought was more porous, better, open, as you would say. The paper just simply allowed better wiping. And then I investigated several underscreen solvents. I I chose Zestron Vigon U60 in the end, and as I started to play with them, I noticed some definite improvements, but it still didn't give me the ability. It gave me ability to clean, but my new SMT line, we had a 22-second mean cycle time, and so the gate or the screen printer was always they stopped to clean for 2.5 minutes. The SMT line would empty of boards, and so I looked for throughput. So my goal was to increase throughput while maintaining great quality, and so that is where the nano coating really made the difference. It allowed me to start cleaning, running much more efficiently without having to stop every 3 to 5 boards to clean.
Yeah, and we all learn early on when we learn about line balancing that your stencil printer should never, ever, ever be the gate on your assembly line.
Exactly.
Your most expensive piece of equipment, which is usually your placer, should be your gate. So if you have a $2 million piece of equipment waiting for a $100,000 piece of equipment to feed it, you're not making a lot of money.
Exactly. That was the case.
All righty. So let's talk about the first few changes you made, the IPA to Vigon, and then the paper. What's the purpose of the Zestron, and the under wipe solvent, I should say?
And so the Vigon, what I wanted to find something that was not harmful to my new screen printer, that was able to work efficiently, able to be sprayed. I also bought several things that remove. I wanted a water-based system that removed the solder. Basically, that's all I wanted. I wanted to be able to clean the stencil the first time around, and that way cut down on the amount of time, because we were wiping the stencil 3 times previously to get it clean. So I wanted something that would clean it right away, and so that is where the Vigon comes in. Something that could be easily handled, and we sell abroad. So I wanted something with the chemical composites that made it possible to sell our product abroad and clean and maintain our machinery in plant.
Now, the water-based evaporates a little less slowly than the IPA, but do you make that up in cycle time because you don't have to wipe so often?
Yes, we make that up because the water-based, while it evaporates a little more slowly, that is true, but we make it up in cycle time because we're able to run so fast, and we're able to clean less often, as you said earlier. We do not have to clean every 4th or 5th board now.
That's fantastic. Now, why was the IPA problematic for you?
We found the IPA to be problematic because IPA, oftentimes it was very hard to maintain our solder viscosity, and also very hard to maintain the machinery. And so IPA, and we found out it did not clean as efficiently as we wanted it to. So we ended up using more of the paper, more of the roll, just to get it clean, and we had to clean more often. So when you have your brick to fall through the aperture walls, the IPA did not assist us in getting it clean. So sometime after you do a stencil clean, most folks out there will know, it may take you to a board or two just to get the print or the bricks to fall through onto the pads on the board correctly. And so we found out we had more problems with IPA. And then at one point, I actually turned off the IPA and sprayed nothing. And I had about the same results spraying nothing as I did with IPA.
We've found similar results over and over again in the lab. Back in the tin lead days, IPA was a great solvent because it dissolved all the naturally occurring rosins in the solder paste. Now that our solder paste, our lead-free solder paste, and our newer ones are comprised of synthetic resins, alcohol just does not cut it anymore. In fact, it makes it worse.
Yes.
We've seen that, and with some solder paste, it can actually gobble them up and clog the apertures versus cleaning them. So we found the same things. This is why I like Jimmy so much. We find the same things in our tests, me in the lab, him and us production line. Now, what about switching your wiper textile? I don't even call it paper anymore. I call it wiper textile.
Right, because this cloth is not a paper, and so
Mm-hmm.
I learned a lot from the folks over at MicroCare about paper. I mean, we had an entire dissertation on paper, and so when you learn how the fibers are made, and I simply, in my layman's term, call it a more porous paper, a paper with more openings. And so, if you were to read not about these new cloths, you will find out that they're designed to absorb better. They're designed to help you get the wipe you want in one wipe. So if you combine a better solvent, a better paper, and then you have a substance which helps repel, for lack of a better term, the solder, it is the magic um, mixture. Those three things together, I found to be the magic mixture of reducing the solder residue or solder buildup, and a good uh, and a good program, a good screen printing program always helps. If you can design a better screen printing program, setting up things like your snap off and your print and your speed, those kind of things together showed amazing results for me.
Yeah, you're absolutely right. You have to take that systemic view of overall. And what I think we've done in printing over the years is we optimize the overall system, and now to get those little advancements, to get to those O201s and those O105s, we're going in and we're optimizing our subsystems. You know,
Exactly.
we're finding the better paper, we're finding the better solvent, we're finding the better paste. And when we do the more porous paper, we like that open structure because it does capture solder balls better than some of the closed structure filled papers. But when we combine the good wiper textile, the appropriate solvent, and the NanoClear to get these kind of results, I like to call it the triple play. And you know how rare triple plays are.
They're very rare.
But we've got a great triple play here, don't we?
Yes, we do. This is the trifecta I found in my experience.
There we go. There we go. And the micro wipe now has helped you because you're getting better printing?
Yes, it's pretty much helped us get better printing, get better, like I said, get everything it relates in dollars, whether it's a loss of revenue, loss of time, it's all dollars in the end, and repair. So here we spent a quarter to save $1. In the micro wipes. It has had a tangible, measurable response. I mean, because we can measure. I'm an FDA compliant environment, and so when I do these things, I have to go back and validate and show what happened. So this has had a measurable effect upon us.
Yeah, and I think one of the big takeaways here is your last bullet, your reduced roll usage and downtime for changeovers. It seems in the 25 years I've been doing SMT, there's a never-ending battle between the process engineers who want good, high-quality, more costly wiper paper and supply chain purchasing agents who want to save the most money. And you're always running, and one day you get this really lousy paper, and you have to go say, no, this is not a commodity, buy the best paper. And I think you just made a really good case study for people investing in good paper.
I agreed wholeheartedly. The thing moving from cleaning every fourth or fifth board to 24th board kind of answered that question. And I respect the bean counters, but it did put that argument, or it did make a justification, I should say. It did make a justification. We should justify the cost.
They do, and a lot of times you need to do a few extra wipes because your paper isn't as absorbent, so you're losing it right there.
Right.
Here's some pictures you provided us of the difference between using the micro wipe dry and what we've known for years is some of the best paper in the business, Sontara with the IPA.
Mm-hmm. And so yeah, these pictures show an example of when we were doing our studies, what you would see. And so we replicated what you see on these pictures. So
that's amazing. You can see how the IPA can actually help that solder base congeal and cling in the apertures versus releasing. Well, now we're getting to your magic bullet, the NanoClear.
Okay, so the NanoClear, like I said, was the missing piece of the puzzle. We did all the things we were aware of, and so I did everything I was aware of, and so I did not know. I learned about NanoClear at one of the IPC conferences, and then a friend of mine actually told me that give me the things you're trying to do, there's a few people already out there doing it. That's when I was introduced to Aculon, and then I was introduced to Miss Chrys Shea, and I watched some of your videos and found out you guys were already doing the very thing I was trying to do in a production environment. And so the fact that you guys are scientists, I pretty much I understood everything you guys were doing, and you guys were doing it much better than I was, and you didn't have to wait for the available time on the lines to do it. So when I added this Aculon, the NanoClear, it was a missing piece of the puzzle. It allowed me then to, my goal at that time was simply to double my screen printing variation. So instead of cleaning every 4th or 5th board, I hope to clean every 8th or 9th or 10th board. That was my goal, and still maintain quality.
And we generally say that you can double your wipe frequency when you nano coat. That's pretty much a rule of thumb. So you were going after the rule of thumb. And now here we're starting your business case. Here we've got the business case where you're wiping every 5.
Right. And so we were doing the typical wiping every 4 to 5 boards based on the severity of the stencil. If it was a 4 mil stencil with maybe BGAs and PBGAs, maybe it was every 4. So it varied between every 4, let's say, and every 6. 5 was the average. And then we were able to get comfortably on several products to 25 cycles. Not every product, but several products. So that was certainly, and we kept pushing it just to, and then we have to remember this is in a production environment, so we don't get to really make a lot of it. These are boards that were going to go out the door. So we did this in a production environment, and we had to validate all of this was working. So we did all of this, and we were able to prove that we could run with 25 cycles, and our AOI machine and our ATE testing saw no reduction in quality. So this was a very measured event, and we were able to save a lot of time.
That's amazing. And you also bring up a good point there. In production, you can't test it till it breaks like I can in the lab. You just have to keep nudging because you can't you can't build broken boards.
Exactly. They all had to work. So.
All right, so now we've got your calculations for the throughput improvements you are hoping to get. Yes,
and so we had very conservative numbers we were hoping for. I simply, while reducing defects was certainly a part of it, we kind of figured if we just get a better process, we could reduce defects. So I was hoping to keep up with my very fast SMT line we had just purchased. So I was hoping to get it just a few seconds, so the screen printer wouldn't be the gate, as you said. And so, but the results turned out to be pretty amazing. As you can see, we just blew away anything we could possibly thought would ever happen.
That's amazing. That's amazing. The 35% throughput improvement over the course of a year, that's got to add up to big dollars.
Yeah, we tried to, at the time, I was installing I had several projects, Big Brother software to make us a smart factory, a brand new SMT line, and I was learning all these new things. So this is very conservative numbers, but we measured the throughput, and so we were able to, we had a faster screen printer, a faster SMT line, and this process allowed us to maintain our integrity, maintain and improve our quality by also running faster. So if you can run with better quality and higher throughput, that is the magic that everybody's looking for.
Well, we always had jokes as new product engineers. Do you want it fast, cheap, or good? Pick 2 out of 3.
Right.
So is it really possible when you're making it faster and less expensively to make it better?
It was possible in this scenario, and I should say that as a caveat that this was a brand new SMT line. So we were able to make things faster because of the products we built. But as you know, the first process in the SMT line is the screen printing. And like I said before, everyone agrees that about 65% of your defects originate at that place. So to me, this was low-hanging fruit once again. I was going to attack where I saw the problems were. I could build faster. I could have a new SPI machine. I could have one machine act as big brother for the other one, but I needed to get the defects down. So this allowed me, since so many of our problems were concentrated at this one machine, I think by handling the highest point of where most of our defects originated from, it allowed such a huge turnaround. And the Aculon provided the magic bullet, as it were, to increase our throughput. And so once we increased that throughput and we were able to build better boards with less defects, it was just no stopping.
So you got your throughput up by a third. And in the meantime, your Co-Young Zenith is telling you have 52% less defects.
Yes, we were able to, because we were able to now measure, because we have Co-Young SPI and AOI, we were able to take measurements and compare how we ran before and how we ran after. And so it showed that things that were, even though we were wiping every fourth or fifth board, we still had, so as I said before, even if you wipe a board, typically the next board is not great. It takes the second or third board before you really get running again, and by the fifth board, you're wiping again. So the process innately has problems on those one or two boards initially. And so when we were able to wipe a board and the next board came out perfect, and we were able to spread that out to the 5th, 10th, 15th, 20th board, and yet our SPI showed no defects, we were quite amazed. And it took some convincing, I might say, because these were unheard of numbers, even for me.
You know, sometimes I run tests and I say, if I weren't the one collecting the data, I wouldn't believe the results.
Yeah.
I think that's the case for you as well, right?
And I'm a process engineer, not a scientist like yourself. So it was a little tougher for me. So.
But so that means now the less defects at AOI, you're probably also getting a lot less false calls at AOI. But your operators are picking up soldering irons and taking them to boards only half as many times as they were before.
Yes, it is an amazing thing not to have, as you all know, a solder joint made in a reflow oven is infinitely better than one did by hand. And
oh, yes.
When someone repairs something, there's always possibility of destroying pads on the boards or not using the right solder, because we still use both leaded and lead-free, the old 10 lead stuff. So it's lots of errors. You just want to build it right the first time. That's all you really want.
Oh, yeah. I did MRB for a couple of years, and some of the nightmares that come out of rework, from bad rework, kill you.
Yeah, they kill you. We've suffered things. We've had migration issues and all kind of things. So we just want to build it right the first time.
Oh, yeah. No mixing fluxes, no scorching boards, no DLAM, no mixed metals. Yeah.
It is an infinite number of things that you have to address if you're going to repair boards and try to inspect your way into quality. So
that's absolutely right. You're absolutely right. You've said a couple times in our previous conversations you cannot inspect quality in. No. You have to build it in.
Yeah, you cannot. Making better processes is worth the time, money saved, and to save effort and time and money. And you get a higher degree of confidence when you send those boards on to ATE or functional test or someplace else.
Amen. And now looking at ATE, that's the really expensive defect to find when you find it at ATE. We have the rule of tens where, you know, if you find a bad print at SPI or at the printer, it costs you $1 to clean it. If you find it after reflow and you have to take an iron to it, it costs you $10 to clean it. If you find it at ATE, it costs you $100 because you have to run the test twice. And if you find it in the field, it costs you $1,000. Now, when I started over 25 years ago, we used to say 50 cents, $5, $50 and $500. So I've adjusted that rule for the time value of money.
Yes.
But the point is, ATE defects are expensive because those test stands are expensive, those fixtures are expensive, the overhead rates are expensive. If your tech has to test it twice and he's the one taking an iron to it, that's a little dangerous as well. So getting those down is probably a larger cost savings than getting the SMT defects down.
Right. We wanted to put some of the AT. We have in AT. We have a great bunch of folks down there. We have a BGA repair machine. We have lots of special machines to do repairs. We really want to put them out of business, honestly. So it is They do a great job, but we really want them to not have to do those repairs anymore. And so that is our goal.
All right, that's an excellent goal. Put the rework people out of business. I like that goal. All right, so now that brings us to the cost savings of the payback calculator that I created for Aculon a couple years ago that you can just download online either from their website or mine. And it's very easy to use. Everything is transparent. There's no lock cells. There's no hidden calculations. It's currency neutral, and it gives you a couple different options. So why don't we walk through the business case that Rauland has used. Now, Jimmy, your interns put this together for you, right?
Yes. This particular cost savings is separate from the study. The study was done over a 6-month period on a brand new SMT line, comparing it to the output of old SMT lines. So the study was different than this. What you have in front of you now is something my interns did this summer when we of course, we took all of the findings on our new SMT line when we completed the study, and we rolled those same processes back to our older SMT lines and our older screen printers and our older machines, and we did the same work, and we tried to funnel that work into our older SMT lines to see what kind of results we would then gather if we did the same thing on other lines. So, and I think that's what most people would be. Most folks would be applying this to an existing line or an existing process, and so we found that once the interns did their study and they went around, they collected the cost and the time it took to repair defects, whether it's a complex or a simple, whether it's at SMT or at ATE, AOI, or ATE testers, what the cost would be. And so this is what my interns presented me in their final. We asked them to give a presentation at the end of every summer. Now every intern wants to give a great number, how he saved that company $1 million in 3 months, but I went through their numbers and I found this to be very accurate of what they presented to me. So I gave it to you just as they gave it to me this summer, and they did a lot of great work.
All right, and for people who aren't familiar with this, you enter information here, the time required. We say simple rework is something that uses hand tools, an iron, braid, wick, solder sucker, and complex is something that uses a special machine like a BGA or a QFN. So you guys have calculated the time required for simple rework for fixing and logging the defect is about 4 minutes. This is your local labor rate. And we usually default benefit and overhead rates to 25% in the US and Europe, and probably 15 to 20 depending on your location in Asia. Again, you can change all those. So these add up to cost you about $2, $2.50 to take an iron to the board.
Right.
Complex rework takes about an hour if you're really getting into an intricate BGA or QFN. So your complex rework is a lot more expensive. That's about $35. And here you just enter the cost of your wiper paper, the length of the roll, how many advances you use on a wipe, and the average advance per wipe. And when you look at your solvent, here's the cost of your container, how many liters are in the container. Your typical dispense rate that we measured off a deck machine is about 2 milliliters, and you usually do 1 solvent pass. So every time you wipe, you've got about 3 cents of paper and 2 cents of solvent. So it's about 5 cents in consumables per wipe, which also takes a lot of cost out when you go from 5 to 25, right, doesn't it? All right, now for the new users, these numbers in yellow feed into the next sheet here, and you'll see them in here under the cost reduction banner. So do you want to walk us through the quality and productivity improvements, Jimmy? So
the quality was across all 4 lines. They took an average across all 4 lines. Some lines obviously run better than others. So the quality, they determined to be 80% first pass yields across all 4 lines. And so the goal was actually 99%. So the number of defects requiring rework, they found that 90% of them were simple, and only about 10% were the harder things to repair. And so the current wipe frequency and productivity, as I said before, was about 5 as an average, and we projected wipe frequency was 24. So you can see the reduction at 79%. That is the big number that helps us justify the cost of anything else. And so that right there, if you can safely and in a repeated manner get just double your number from 5 to 10, most time you see a huge savings. Our cost reduction in the simple rework, the cost of complex rework, and the cost of wipes, those are numbers that Chrys just went over earlier. And the payback period, the savings per print, the cost of the NanoClear out a week is not is $20 we have here. Cost of application is 20, and the payback is 43. Now those numbers are very conservative. The cost of application, once we got really good at it, became almost half of that because we were able to do it in much less time. But you can see a video at Aculon to tell you how to do it. The number of prints per hour, 90. The production hours per week are 80 hours, and the number of paper rolls per week, it says 17, but it's not quite that many anymore. Time to change the roll, 5 minutes. And so you can see this is across, this is what you see here is an annual savings, not the 6-month savings, but an annual saving across 2 shifts. And so you can see it was quite a considerable savings. We were able to extrapolate from our numbers. Now our numbers come from the quality group. The quality group, at the end of the EAI, we write down, and also the EAI saves the defects. So we have 2 sources where we save our defects, and at ATE, they also save the defects and write them down, and you'll get a report daily on what they saw the day before. So daily, someone is reporting what kind of defects you put out the day before. So before that, I always hated that number. Now we look forward to that number. So every time they put out a number, we go back 6 months and we compare and show we're getting much, much better.
Excellent. So now the annual cost reduction that you see here, that's based on the savings per print and yield improvement and the defect reduction. Also, because you're not changing wiper rolls so often, you're getting an extra 52 hours over a shift week of extra production in a year.
Yes, yes.
And according to the numbers you put in, that equals, about 4,600 boards.
Yes.
So when it comes to the bean counters and they don't want to pay for better wiper paper or $40 stencil applications, we can ask them, okay, if you could make an extra 5,000 boards a year, what's the average sales price of a board?
Yes.
The cost of the triple play pales in comparison to the benefit, no doubt. Now, one of the notes I want to make on here is we showed the savings per print, and we did this math here on a single stencil. And usually, regardless of the yield improvement, we will see a payback in less than 200 prints. Mm-hmm. Now, this number here, the 395,000 and the 5,000 extra boards per year, is based on all 4 lines, which means you would coat all your stencils with NanoClear, which I think you did. You said you had about 200 of them. Yeah, so $25 an application. You're looking at a total investment across all your stencils, about $5,000 to save $395.
Yeah, we nano-coated all of our stencils, and that led to, in turn, a stencil database, which we created. And in that stencil database, we barcoded every stencil, and we nano-coated, and it's indicated in that database which stencils have been nano-coated. And also, we have the Aculon test pen, where every quarter, one of the process people go out and audit every stencil in the building, and we check to make sure our Aculon is still working, but that the quality of the stencil. And so we've created a process by which we maintain all our stencils and we audit them every quarter.
That is a fabulous stencil maintenance program. It's a best practice. I hope a lot of listeners pay a lot of attention to that, because so many defects are made to stencil printing, and so many broken, dirty, or busted stencils are put back in the racks that as a best practice, managing your stencils is critically important. So I think you took that triple play and then you turned around and hit one out of the park.
It was such a win that our management, our EMT group, wanted to make sure that we did not lose the effectiveness of the Aculon. So Aculon was the reason for the database. And so I will not pretend I was very excited about having to inspect stencils every quarter, but they wanted to ensure that the Aculon remained active. And so we also bought in our stencil cleaning instrument, we have a detergent by Zestron, which that's very friendly should I say, to Aculon. And so we have Zestron both in our underscreen printer solvent and our cleaning, stencil cleaning machine. So to make sure we built a lot of processes around maintaining the Aculon coating, NanoClear.
That's good, because as most of us know, it doesn't matter what nano coating you're using, they do wear over time as a result of the abrasion of the paper. So to make sure it's active is very important. And it's also important to note that with the Aculon that you wipe on, if it starts coming off, you can put it back on again. You don't need to scrap the stencil and buy a new stencil with a semi-permanent coating. Also, if you're already running stencils, that was another point, you can pull the stencil off the rack, clean it real well, and apply the NanoClear. You don't need to buy a new stencil to get a nano coating on it. And I think the flexibility of the Aculon in that respect is a real winner for nano coating users. Yes, we were able to apply NanoClear to over 200, let's say 230-ish stencils. And I did the first few, and I taught another engineer, and then he taught the intern. So it is not a very sophisticated something that someone can learn to do. It was very easy to apply, and it was very effective. And then there's a test method too that you can use to make sure it's been applied correctly. So. Yep. I carry packets with me. So when I run into somebody's stencil printing problems, I'm like, hey, let's try this. What do you know? And one note on that, when you apply it too, is it asks for DI water. If you don't have DI water, which I don't at my house when I coat a lot of stencils, I use tap and then just do a rinse with distilled from the grocery store, and it's fine. So if you're watching the application video and you see DI water, don't let it put you off. It works pretty well if you just do a rinse with some distilled. So now we just want to talk about how to get the best results out of your NanoClear. And the first thing is make sure you have a nice clean stencil before you apply it. And even if your stencil is brand new, fresh out of the box, you need to clean it before you use it, because even brand new stencils have a lot of debris in their apertures. Cleaning solvents, maybe sometimes there's oil in there. I've picked up oils on SEMs, don't know how. A lot of times you'll see lint and that type of stuff in there, so you want to clean them. And we've also found that the softer wipes, such as the MicroCare micro wipe that Jimmy's using, or Deck Eco Roll in the US and HyperClean in the rest of the world, from internal testing at Aculon, show that these are the better wipes to use that will help preserve the structure of the NanoClear. Use a good underwipe solvent like Jimmy switched from IPA to Zestron. A couple issues with IPA that we mentioned, how it can change the viscosity and actually make the paste clog the apertures. We've had situations where people are suffering with aperture clogging. They apply nano coating and they still have the aperture clogging, and they're wondering why the nano coating didn't fix it. It's usually because they're still using IPA as a solvent. So that's another good reason to get away from IPA and get into these engineered solvents that are specifically for your solder paste. Wipe less frequently. Obviously, you've seen you don't have to wipe as frequently. The less abrasion you put on the nano coating, the longer it's going to last you. Don't soak your stencil in the cleaner overnight. That's a general thing. Oh, so many times second shift to leave a stencil in the cleaner, soaking in solution, you come in the morning and find it. It's not really going to attack the NanoClear as much as it's going to attack your epoxy bonds, and your stencil is going to delam. So that's just good stencil management. And as Jimmy said, in stencil management, periodically check that with the dine pen to confirm its activity. And if it's starting to lose activity, just open up a pack and apply another. Any other tips or tricks for getting the best out of your NanoClear, Jimmy?
I would say pretty much you've gone over it. Just I did some studies with Vigon where they showed how their product, if you ask your solvent manufacturer for some studies, most of them have studies they've shown to work with different types of NanoClear or different type of underscreen coatings. You can ask for that data. I was forced to ask for that data in my environment, FDA compliant, and so it always, you will know ahead of time what you can expect.
All right, excellent. And now I think we'll turn it back over to Edward to summarize the nano coating product for us.
Well, that was terrific, guys. I mean, really a great story about how you've taken a very engineering process improvement based program and just got terrific results. So we're delighted to be part of it. We are thrilled with how NanoClear is going. I mean, globally we are the number one, and it's doing well. It's we like to tell people, and maybe Jimmy, you could even comment on this. Sometimes we get people that just say it's we only use it on our problem stencils. It only the ones that are really hard to print. And we go back and say, look at if you look at the cost savings calculator, it pays back very quickly on all of your stencils, and so we recommend it for all of them. So I mean, did you just use it for the fine pitch stencils, Jimmy, or was it for every one?
No, I use it for everything. Of course, I went for a dramatic increase, as you saw. It is my way, and so I wanted to see every defect. I went for a holistic approach, so I used it on every stencil, no matter how simple, whether it's just a bunch of uh, uh, SOPs or something very simple, or fine pitch BGAs or QFNs. I wanted a cross the board improvement, and so I used it on every stencil and every product, and I expected a result across the board. And so I found it to be it's cheaper than buying a new stencil. A new stencil can cost you $450. The Nanocoat could be 20, 25 bucks, and the results are amazing. Just in the savings, I would say in the first, depending on how many boards you build, in the first build alone, you could probably make your money back.
Well, that's great. I mean, as you showed in that cost of ownership calculator, I think your payback was within 43 prints, which was terrific. And so, we like to think, obviously, you're going to get improved quality, you're going to get the productivity, and essentially, the costs are going to be free. So hopefully it's a real win in doing this. And what we've seen, and Chrys has been a big advocate of this, is there are ways to continue to enhance the durability. And so, what you're doing with the softer wipe paper is exactly what we recommend, because we like to use the analogy: if you have a cast iron pan, you had to use a very tough kind of metal Brillo pad to clean it. But if you've got a Teflon pan, you use a softer paper, and that's exactly what we've done to stencils now. We've made them more like a Teflon pan. So use a softer paper, and you're going to get much greater durability out of it. So we're thrilled about that, and we are delighted that you've been able to demonstrate higher quality. I just had a couple of questions before I open it up. I know that people in the who are listening, please type any questions you have in the question box. But obviously, Jimmy, you did a pretty rigorous process. You changed the wiper paper, you changed the under stencils cleaning solvent, and you changed the NanoClear. If you were to do it again, would you do it in that order? Or how would you recommend to other people who are looking to kind of emulate some of the results you've got?
I think if I were to do it again, I would immediately start with the NanoClear, the my underscreen paper, my white paper, and the solvent. I would start right there. I would in that order, because it's easy to get your hands on NanoClear. It's very easy to apply, and so I would start there. It can be, you may have to buy or get some manufacturer to give you some free samples of their solvent, or you may have to try to convince someone to buy the more expensive paper. That usually is the last thing. Justifying the paper, you have to really, in my experience, just already show some improvement. So I would start with the NanoClear because it's so inexpensive, it's so easy to do, and then I would move to the solvent, and then lastly the paper. But I wouldn't expect the amazing results until, in my opinion, in my scenario anyway, I didn't get the amazing results until I got all three of those things working in conjunction.
It's a triple play.
That's what
Exactly.
it's a triple play, exactly. So are there, I mean, there must have been some pitfalls or problems in this process.
The only pitfalls that I ran into, because I was so geeked up about the experiment, was that what I didn't know, and so I didn't know what to test. I didn't know if I needed to change my program in my machine. I didn't know my underscreen, my Plymouth, my underscreen cleaning device they're not the same in every machine, and so I wasn't sure if I would get the same results. One has a very wide mouth, one has a very small mouth, so it's going to be different. Every manufacturer of a screen printer has a different under-screen cleaning device. So I had to find a happy medium when I rolled this out. So the only thing was making it work in my facility, understanding my machine, and having a better understanding how to create a great profile or program at screen printing, and then applying the NanoClear and seeing the results. So the only thing was getting started and what I expected to see, and my own understanding. Now I can say that I was about 60% into my experiment when I discovered Chrys and what she was doing, and so it helped me a lot. I didn't have to reinvent the wheel, and so I would say if I had to do it over, find someone that's already doing it and just listen to them. I read a lot of white papers, but I did admittedly get started before I knew exactly what I was doing. And so if I had to do it over again, I would read more white papers. I would watch a lot of Chrys Shea videos and NanoClear videos before I ever get started.
Well, that's great.
Well, that's a fine endorsement. Who's buying you dinner next week? Edward or myself? No.
I'll take either.
Let's go to the next slide, and I've just got a couple of questions that are coming in here. So once again, I mean, everything's going to be emailed to you. The videos instructions are online. You'll get this presentation with the links. If you have any questions or concerns, Mary Gattuso, one of my colleagues here, will deal with that. This cost of ownership calculator is downloadable. The question came in, can the stencil fabricator apply the coating? And I guess if so, why did you do this at your own facility, Jimmy?
Yes, the stencil fabricator can apply the coating. You have to see which coating. Everyone does not apply Aculon, obviously, and so you have to see which coating your manufacturer applies. And so that would be the first thing to do. And then after that, and you want to know why did I do it myself? Because the stencils in-house, we had 4 SMT lines worth of stencils, and it was pretty hard to go justify on this particular SMT line. I think there's 30 stencils. It's pretty hard to justify 30 stencils for a product I had not even proven yet. So I did it by hand, and I found that it worked very well. And now my stencils, as a default, our stencil maker sends us nano-coated stencils as a default. My stencils are always nano-coated when I receive them from my stencil manufacturer. And so, but initially, to justify, I did them all by hand, and I didn't have to replace 230 stencils.
Nice.
That's great. Okay, so you made a comment, and just looking at this person's question, you made a comment about the cost of the stencils, about $400 and something dollars. So these sound pretty high-end stencils. Do you use any lower cost stencils in your process and apply NanoClear?
My present stencil cost, I'm not saying everyone get this price because I do these demos, but my stencil cost today is $375 stencil with advanced nano coating, not just nano coating, but we have an advanced nano coating. But my default stencil is a 4 mil stretch stencil, advanced nano coating, and a few other specialized things I threw in the mix. But that is $375 is what I'm paying today.
Okay. And Chrys, I know you've looked at the impact of nano coatings on different stencils, and so I don't know whether you have any perspective on this question.
I do. Well, my perspective on stencil quality is always clear. I always buy on quality, not on price. And if quality slips, start looking at other stencil shops to make sure you maintain your quality. Now, that said, the NanoClear helps any stencil. I wouldn't suggest, going out and trying to buy the cheapest stencil and putting a Band-Aid on it with NanoClear, but it helps every stencil it's put on. I've never seen it not help improve a process, and I've been working on it since 2011. So yeah, you can apply it to any stencil. I mentioned that I carry it with me in my bag, a pack or two all the time, because if I'm in different customer sites, not everybody is using the best stencil they can, and you can see stencil problems. You can see stretch or dimensional instability, overcut, you see bad gasketing, and you just whip out a packet of NanoClear and put it on, and it can make that bad stencil work really well. And I think the biggest benefit, like when you really dig down in the process details, why it benefits poorer stencils as well as good ones, is you get bad gasketing when you have bad cuts, and NanoClear is so forgiving when you have bad gasketing. You have bad gasketing, you get that solder paste pumping out and contacting the bottom of the stencil. It's separation, it's that big string that makes the mess. When you have the nanocoating on there and that pump out sneaks out and it's between the stencil and the board, when the stencil separates, it repels the paste. So you don't get that big string that flops over and makes bridges and messes. So it's a great forgiver for bad gasketing. And I don't think anybody on this webinar has not had issues with bad gasketing in their printers.
Okay. All right, you got a good question here. And why did you apply it to all the stencils when some of them will print just fine?
I applied it to all the stencils because I assumed that we were having some type of defect. And so some of the stencils, we applied it for multiple reasons. While we only talk about defects and throughput, we applied it to stencils because some of the stencils showed the rubber band effect, or the snap off wasn't so good, or some the gasketing, just as Chrys has just mentioned. So there was a variety of issues which we didn't address here that I used the nanocoating to overcome. Some of the stencils just weren't very well designed, and some of the stencils were for legacy products, and we weren't going to buy a new stencil. So it helped me overcome a variety of issues. So instead of trying to, at that time I didn't have the database, and so instead of trying to get the history of every stencil, I simply found it easier and inexpensive just to cover every stencil and then look for an overall drop in defects across the factory. And so my goal was to have an overall drop in defects across the factory instead of firefighting each particular product, because we run a large number of products. My thing was just to do a wide swath, funnel the process or my findings from the new line back to the old line. So it was I went for and since it was 25 was relatively inexpensive, and since my interns were relatively inexpensive, I got a chance to do it all in one fatal swoop.
And even if you're yielding 100% and you don't think you need it, you're just still going to make your money back in the wipe consumables and the downtime for wiping. So even a board that's yielding 100% can benefit from the NanoClear.
Okay, great. I think that pretty much covers the questions that I've got coming in, so we can go to the next slide. And so this is the contact information for Mario, myself, and Chrys, and I think that probably pretty much wraps it up. So with that, I want to thank Jimmy for participating in this thing. It was great to hear the story, the real true life case story of how you've used this as part of a process improvement program and delivered on cost savings and quality improvement and throughput. And thank Chrys for her continued work in research in this space and really working hard on helping people solve process problems. So it sounds like you guys are very much in tune on that, and we're happy to play a part, and hopefully we'll see other people have the same kind of results. And so with that, Jimmy, thank you, and Chrys, thank you very much, and we'll be closing the webinar now.
Thank you for having me.
Thank you. My pleasure.